The purpose of this video is to discuss how to solve a linear inequality such as 2x plus 5 is less than 17. Now first let's just recall how to solve a linear equation such as 2x plus 5 equals 17. To solve this equation we would subtract 5 from both sides and we would get 2x equals 12, and then we would divide both sides of the equation by 2, and we would get our solution, x equals 6. Now the question for us to consider is, can we solve this linear inequality in the same way that we solve this linear equation? Can we subtract 5 from both sides of the inequality? Would the inequality stay true? Well, in order to explore this, let's start with an inequality that we know is true. For instance, 6 is less than 15. Now let's first add 4 to both sides of this inequality and see if the inequality remains true. 6 plus 4 is 10, and 5 plus 4 is 19. Well, 10 is indeed less than 19, so if we add 4 to both sides of the inequality remains true. Let's try subtracting 8 from both sides of the inequality. 6 minus 8 is negative 2, and 15 minus 8 is 7. Negative 2 is less than 7, so if we subtract 8 from both sides of the inequality remains true. Now let's multiply both sides of the inequality by 2. If we multiply both sides by 2, we get 12 on the left and 30 on the right, and 12 is less than 30. Now let's divide both sides of the inequality by 3. 6 divided by 3 is 2, 15 divided by 3 is 5, and 2 is less than 5. Now let's multiply both sides of this inequality by negative 4. 6 times negative 4 is negative 24, and 15 times negative 4 is negative 60. Now this time, negative 24 is not less than negative 60. In fact, negative 24 is greater than negative 60. So when we multiply both sides of this inequality by this negative 4, we have to switch the direction of the inequality in order for it to remain true. Now let's take the inequality 6 is less than 15 and divide both sides by negative 1. 6 divided by negative 1 is negative 6. 15 divided by negative 1 is negative 15. And negative 6 is greater than negative 15. So, what I hope you've seen is that if you add, subtract, multiply, or divide both sides of an inequality by a positive number, the inequality remains true. But if you multiply or divide both sides of an inequality by a negative number, we have to switch the direction of the inequality in order for the inequality to remain true. Now, let's return to our inequality 2x plus 5 is less than 17. So what we've seen is that we can indeed subtract 5 from both sides of the inequality, and the inequality would remain true. So I keep the inequality going in the same direction. And we'd have 2x is less than 12. Then we could divide both sides of the inequality by 2, and we would get our solution, x is less than 6. So that means all of the values of x that are less than 6 make this inequality true. And if we were asked to graph our solutions on a number line, we would graph all of the numbers that are to the left of 6, not including 6, so we would put an open circle around the 6 and shade all of the numbers to the left. Now, let me give you an inequality to try to solve. Take the inequality, let's make it 38. 38 is greater than or equal to 8 minus 3x. Take a moment and pause the video, try the problem, and once you've done with the problem, hit play. So, to solve this linear inequality, I'm going to start by subtracting 8 from both sides. And since I'm subtracting a positive number, I would keep the direction of the inequality going in the same direction. 38 minus 8 is 30. So 30 is greater than or equal to negative 3x. In order to isolate this x, we have to divide both sides by negative 3. And since we're dividing by a negative number, we have to switch the direction of the inequality. And 30 divided by negative 3 is negative 10. So our solution is negative 10 is less than or equal to x, or if you prefer, you could write that as x is greater than or equal to negative 10. And if you graph the solutions on the number line, we would graph all of the values that are to the right of negative 10, including negative 10. So I'd put a closed circle on negative 10 and shade all of the points to the right. So, just to recap, when solving an inequality, it's almost the same as solving an equation. If you have to add, subtract, multiply, or divide both sides of the inequality by a positive number, you keep the direction of the inequality the same. If, however, you multiply or divide both sides of the inequality by a negative number, you must switch the direction of the inequality.